Okay. Hello everyone, welcome to the FusionVerse event. My name is Balasiva and I'm going to show you the
Hello everyone,
basics.
welcome to the FusionVerse event.
So I'm going to show you the basics of Fusion 360 and let's get started. Okay, I hope you have installed Fusion 360. If not, you can check our installation guide over in our channel. And what I'm going to do now is that you can see this is my desktop. We're going to open Fusion 360 and here we are. Let's wait a minute to get it loaded. Okay. So we can see that we are in the main screen of Fusion 360. But if this is the first time you're opening Fusion 360, it will ask you for a team name. Just enter some random name and get into Fusion 360. You will get this main screen. And okay, now what you have to do first is we can go to the top right corner. You can see this icon over here. It says your name, and click on it. Go to Preferences. Let's wait a second to get it loaded. And we can see there's a bunch of options over here in the menu part. And we can see that there's this part called as default units. Under that, you'll find design. Click on it. And you'll find the default units for the new design is given over here. Switch to if it's some other unit for you. It'll probably be defaultly given as millimeters for you. If that's the case, don't do anything. Just leave it as such. All you have to do is click on apply and give OK. So okay, we can see, as I said, this is the main window of Fusion 360. This is the 3D workspace. Here you can see a bunch of icons over here and over here as well. I'm going to tell you what they are in just a second. Okay, we can see that this is like the part where you can choose the different views of your workspace. This is the top view of the workspace. This is the front view, and we can see the side profiles as well. And we can do one cool trick. We can keep this over here. This will provide you the isometric view of the model that you're working on. Let's put it to front view right now. Now we can see that there are a lot of icons over here. These are the tools that we are going to be using. We can see that there is solid, surface, mesh, sheet metal, plastic, and other utilities. We're just going to focus on solid because this is the basics, as we can see. And you can see there are a bunch of features over here. Design, generative, render, animation, simulation, etc. This just showcases how much you can do with Fusion 360. So, okay, let's get started. The You can navigate around this 3D workspace using two tools. One is your middle mouse thing, the scroll wheel. You can zoom in and zoom out using the scroll wheel, as you can see. So we can, comfortably use our, you know, view our model. And what we can do is we can click on the middle mouse button and we can pan around. Or we can easily go over here and click the pan icon and you can pan around easily to view your model. Okay. So we're going to create the first component right now of our entire assembly, and I'll show you what we are going to create as a final product. This is the render of our final product. This is what we are going to create. So we are going to create the first component, and this would be the plate drawing, the plate model over here. You can see this would be our final plate component, and let's just check out the dimensions and what we can gather out the information we can gather out of this drawing over here. So we can see that this whole plate, let me zoom in a little bit. Okay, we can see that this whole plate is, there is this huge circle that is over here, and what we can see that is if we extrapolate over here, I think this is not visible over here. I'll just show you the drawing inside of Fusion 360 itself, so it's much easier for you. Um, Give me a second. Yeah. We're gonna wait for it to load. And yeah, this is the final component of what we're gonna create. Let's switch to the side profile and double click on sketch. And we can see that we can see all the dimensions that we need to know. And okay, we can see that this part, like this whole arc, is, a big circle that we just cut down to this arc. And if we can zoom in, we might be fooled to think that, this might be a whole straight line until here. But, if you zoom in, you can see that this is actually an arc, and this arc is a part of the bigger circle over here. So we can keep that in mind when we are working on it. And okay, let's create this circle first. We can see that the diameter of the circle is 45 millimeters. So we're going to do just that. We're going to go to a new design over here, or you can go to the file icon and create new design. Okay. We're going to go to the front profile because that's what we're going to be working on. Go to create sketch over here and select this front profile again on your 3D workspace. Okay. Now we need to create a circle, right? We can see that there are a bunch of options over here in the create module. You can see the circle is over here. You can either click on the circle or you can use a shortcut key, which I'll tell you in just a moment. We're going to click on the circle tool. We're going to create a circle of 45 millimeters in diameter. So this input over you can see over here is the diameter of the circle. As you can see, it says specify diameter of circle. So we're going to give us 45 millimeters. So we're going to zoom in just for our convenience. Okay. Yeah. We're going to go back to the drawing to see what we can, where we can proceed from here. And you can see that there is this line coming down, which is 10 millimeters in length from this part, which, if you stretch like a imaginary line over here, this is from the center of the circle, and it's, perpendicular to this axis. So we're going to do that. Okay. What we can do is, go to the line tool over here, click on this line tool. Okay.
Don't interrupt him, please.
Okay, yeah. Sorry for the slight delay. Yeah, we can click on this line tool over here. And what we can do is we can hover over the center of the circle and we can slowly take this to the point on the circle. Make sure you do this slowly and on the line itself because you don't want it to go away from it. So click over here and directly go below. We have a 90-degree angle and give 10 millimeters as your input. Make sure it's in 90 degrees. So yeah. Now we can see that this line would be a tangent of this circle, right? Yeah. Now what we can do is we can create this bottom line over here. And if we think about it, this bottom line's dimension is 45 millimeters in length. Because, if we bring this bottom line over here, this would actually cover the entire circle. This would span the entire length of the circle. Okay, we'll do just that right now. What we can do is either click on this line tool over here, or you can go to the L key on your keyboard. I'm gonna be emphasizing a lot on keyboard shortcuts because they just save a lot of time. Okay, click L on your keyboard or over here. Go to the end point of this line and make sure this is in 180 degrees and give the length of this line as 45 millimeters. Okay, let's move around. And again, we need a 10 millimeter length of line over here. So we're gonna do just that. Click L on your keyboard and go to this endpoint of this line. Give the length as 10. And okay, we were, yeah, 10. We need to have 90 degrees as the angle. Just make sure, otherwise you would create a wrong thing. Okay. Now, as I said before, we need this small arc of the circle. So, and also we need this, this line over here, but we don't know like the distance between this line and this thing. So what we can do is just go to the line tool or L on your keyboard. Just select a random point on this circle and give this as 10 millimeters. Okay. Zoom in. Now we can see that the distance between this line and the bottom line is 12.7 millimeters. So there's a neat trick to do this, right? What we can do is we can click on this sketch dimension, right? Or D on your keyboard, that's the shortcut. Click on this and click on the bottom line first, and then this line, and give the dimension or the distance between them as 12.7 millimeters. Okay. Okay, I'm gonna backtrack here. I think I've made a mistake. Yeah. Okay. We don't have to do that. We have a alternate solution for this. What we can do is we can see the constraints over here, right? There are a lot of options over here. Click on the horizontal slash vertical constraint, and then what we can do is click on this point over here, right? And then press control while clicking the middle of the circle, center of the circle. And we can see that, all these blue lines just over here have turned into black lines. What it means is that blue lines means that there are no constraints placed on them, and essentially what they mean is that they can be moved around, and so that would mess with our final drawing. And once it's black, it means that there is a constraint placed on it, and it can't be moved, and we are good to go. Okay. Now we can do the thing that I talked about, sketch dimension tool or D on your keyboard. Click on this line over here and the bottom line as well. And now give the distance as 12.7 millimeters. As you can see, this line has been moved now, not this line. So also we can see that this has a constraint over it right now. And this is black in color. Okay. Now let's go to the drawing once again. As you can see, there's this line that starts from the end point of this line and spans all the way to the point on the circle in the perpendicular manner. We're going to create that. Go to line tool or L on your keyboard, move around, and click on the end point of this line and go above. Make sure it's in 90 degrees and intersect the circle. Okay, now we'll give escape. And if we zoom out, we can see that we have created this outer portion somewhat, right? But we have these stuff that we actually do not need, like the this part of the circle, this bottom part of the circle, and also this part of the circle. So we're going to remove them, and there's this neat tool that you can use. We can see the modify module over here. You can click the trim tool to take them away, or T on your keyboard. Let's do that. Let's go inside. We can see that when you're hovering over the any component, that it will turn into purple in color. It means that you're gonna just trim away that part of the component. Okay, we don't need this part of the circle. We're gonna zoom out, and we also don't need this bottom circle, so we're gonna take that away. We don't need this part of the circle. Let's just make sure it's yeah. And we need this part of the circle, so we're not gonna do anything to it. We can take this away. Yeah. So we can see that we've completed the outer portion. So we can go to the circles next. You can see that there are four circles, and there are two sets of circles. So I'm going to explain you how there are two sets of circles. If we draw an imaginary line, spanning across the circle, going through the center of the circle, we can see if this circle is mirrored over here, we can obtain this circle. So there is this tool that can be used to do just that. We are gonna go back to this drawing that we made, and we're gonna create this circle over here. It's 5.7 millimeters in diameter, and we can see that the distance between the center of the circle and the bottom line is 5 millimeters, and the distance between the center of the circle and this line is 6 millimeters. So we're gonna go to the drawing, create a circle which is 5.7 millimeters in diameter, and we can use the dimension tool or D on your keyboard, right? So we can go over here again. Yeah, 6 millimeters from this line, right? Click on the center of the circle, and this line, give this as 6 millimeters, and again click on D, center of the circle, and this bottom line, give this as 5. It's already given 5. That's a cool coincidence. So I talked about the imaginary line, right, over here. If we imagine an imaginary line, So we're going to create that imaginary line within Fusion 360. What we're going to do is go to the line tool over here, or L on your keyboard again. There's this, menu over here. We can see the sketch palette. What we can do is click on this construction option over here. What this would do is create that imaginary line that I was just talking about. Go over here. We can see that it automatically selects the midpoint of this line, which is cool. And this will also go through the center of the circle. So midpoint, go through the center of the circle, and make sure it intersects. All right. Yeah. Now we can give escape and make sure you click off of this construction line. All right. Now all that is left to do is to mirror the circle. So go to create, right? This create module. We can see the mirror option over here. Click on it. We can see that there's this option, objects given here. Now the object that we need to mirror is this circle. Click on it, and we need to select this mirror line over here, and the mirror line we are going to use is this construction line we just drew, and we can see that it magically mirrors the circle. Now we don't have to manually create the circle, right? That's the whole point of the mirror option. Okay, now the same thing applies to the top two circles as well. So we're going to do just that. We're going to go back here. We're going to create a circle over here first, and the dimension is the same, 5.7 millimeters in diameter. All right. Now let's look at the dimensions, or the distance between the lines. We can see that the distance between the center of this circle and the bottom line is 25 millimeters. We'll specify that. Click D on your keyboard, right? It's already 25, so that's cool. And 17 millimeters between the center of the circle and this line. Again, D on your keyboard, center of the circle and this line. Gonna give it over here, 17 millimeters. So let's just check again. Yeah. So we're gonna mirror this again, right? Click on mirror, and the object is the circle, and the middle line is this construction line. Click OK. Again, you can see that we've created the final, component. The only thing that is left is to create the, this 3D thing. We're gonna do just that. I'm gonna show you how to do it. We can see that we have this option over here as finish sketch. Before that, just make sure everything in the drawing is black in color. Otherwise, it means that it's not constrained, and it might present you with problems later on. So we're gonna make sure, and we're gonna give finish sketch. Okay, we can see that in the create module again. We can see this extrude option over here. We're gonna click that. Click on the profile which you want to extrude, which is this thing excluding all these circles over here. So you're going to click on the profile that we need. Give the value as 1 millimeter. This means that the extrusion would be 1 millimeter in width. Okay. We're going to go to the direction over here. Give this as symmetric. And the measurement is given over here, half length and whole length. Click on whole length and give OK. We can see that. Okay. We can see that we've created the final model, right? Yeah. So we have done the whole thing, as we can see. So all that is left to do is to go to the next model. But before doing that, you have to make sure that we have saved the component. So we're going to go to the file option over here, right? We're going to save it, or you can go over here, or Control S, anything will do. Click on it. Yep. We can go over here and let me backtrack. Make sure you save all your components in a single folder, because it just makes it much easier for you to assemble them later on, right? We're going to create a folder which we'll give the name as FusionVerse, which is just fitting. Okay, we'll double click on it and we'll save. Before saving, make sure you have given the name of the component, which is plate, right? Okay, give save, right? We can see that it's saved over here. Okay, as you can see, I told you before, right? This is the final render we're going to create, and we're going to proceed with the other component that we are going to do, the second component, which is gear. We'll click on this drawing over here. This is much more clear. All right, we're going to go over here. We can close this window. we're going to go to a new window, which is already created for you. So give front view, right? Now let's study this um, component, the drawing of this component. We can see that this is made of a bunch of concentric circles, right? Two sets of concentric circles, uh, four of them over here and two of them over here. Let's zoom in a little bit. All right. You can see that the first circle is 5.7 millimeters in diameter, and the second circle is 7.7 millimeters in diameter. Third one is 25, and the fourth one is, here it's given as 16, but this is the radius and not the diameter. The diameter would be 32. So we're going to do that. All right. Go over here. All right. Click on Create Sketch and click on C on your keyboard. Right. Yeah, we just clicked on the front view. So click on the origin and give this as 5.7 millimeters diameter. Let's zoom in. Again, click on C on your keyboard. 7.7 millimeters. Zoom in again a little bit. And another one, 25 millimeters in diameter. And the last circle, which is 32 millimeters. Okay. Now we'll analyze the drawing again. We can see that we have another set of concentric circles, two circles, which is 5.7 millimeters in diameter, the first one. The second one is 10 millimeters in diameter. I'm going to remind you that this is the radius, which is given as R. So we're going to do that. We're going to move away from this and select a random point and create a 5.7 millimeter diameter circle. And click at this point again, center point, and give this as 10. Yeah, that's what we need. Okay. Now we'll go over here again. You can see that the distance between these two centers of the circles as 40 millimeters. So we're gonna specify that now. Sketch dimension, right? Click on D on your keyboard or click on this tool. Click on the first center and the second center of this set of concentric circles. Go over here, give this as 40, and we can see that it has moved closer to the circle group. It's still in blue. It's because we still have some work to do. But before that, we can make sure that this goes to black. So click on constraints, horizontal/vertical constraint. That's what we are going to use. Go over to this first center of the circle. Click on it, right? And then while pressing Control, click on the second center. And now we can see everything is in black. And what we can do now is we need to connect these two sets of circles. As we can see over here, there are lines that connect. And what we can do is first we'll have to, just to make sure we are doing it right, I'm going to go to construction line over here, hover over the center of the circle and create one that is 90 degrees. And again, create another one which goes to the bottom and intersects the circle. Okay. Now click off of this construction line. We can go, we're still in the line option, by the way, so we don't have to click anything. Go over here on the point of the circle where it intersects. And as we can see that there is a logo at the point where we started the line. This logo represents the tangent logo. So this means that we are tangentially connecting the circle to the line. So click over here, join this and intersect to this circle. So give escape, again L on your keyboard and go over here, hover over this point on the intersection and join these two circles. Okay, click on escape. We can see that it is already given as a black line, right? Which means it's already constraints. We don't have to worry about it. We can go back to the drawing to see what we have missed. We can see that we don't need the parts of this circle, the bigger circle over here and this smaller circle over here. So we're going to trim that away. Go over here. We can see the modify module. You can see the trim option. You can also click T on your keyboard. Take away this portion and this portion. Okay. Now we can see everything is in black. We have created the complete drawing. Okay. Give escape and give finish sketch. Okay, we can see the drawing in its full glory. We can check out the different views, the front view, and we can go to the top view. But we can see that this is a straight line because we haven't created the solid object yet. You can also go to the school isometric view. Okay. Now we're gonna create the model. Go to extrude. Before that, we're gonna check. Okay. We can see that some parts of the object is given 3 millimeters in extrusion, while others are given as 5. I'll show you which are which. Okay. This central circle, right? The second one, and this external part over here are 5 millimeters in extrusion length, and this one is 3 millimeters. So go to the extrude tool, click on the center one, and click on this external one as well. We can see that both are selected. Give 5 millimeters in length, and make sure you go to direction and change it to symmetric. And whole length, make sure you do this as well, and give OK. Now we can see that we are presented with a problem. The sketch we've originally done has disappeared as soon as we created the model. As you can see, this is the model. What we can do to solve this is you can see this menu over here, and we can see the sketch. Click on this drag down menu, and you can see that this IA is disabled. Click on it to enable it. We can see that the sketch is back. Okay, so we're gonna click on extrude again. Click on the plane you want to work on, which is the center circle, right between these two extrusions. Click on it. Give 3 millimeters. That's what we need. Go to the direction. Give it as symmetric and whole length. And yeah, now this might seem normal, like everything is in the same level, but when you go to the isometric view, you can see that there's a difference in height between everything. So this makes sure that we've completed the whole drawing. Okay, we'll, we'll do that. We'll hide the sketch as well. Okay. Now what we have to do is save this component because we've completed the component. You're gonna go to the next one, give save or Control S on your keyboard. Make sure you are in the same folder as before. The name of this component is gear. Make sure you save this. Save. Okay. So we can see that this is saved. We can close this for now. We have completed the component. We're gonna go to the next component. Go here. The next component, the name of the next component is link. Right? This is the drawing of the link. Let's make sure we are zoomed in. Okay. Now, again, we are presented with two sets of concentric circles connected by two lines. So the center circle is 5.7 millimeters in diameter, and the outer circle is 10 millimeters in diameter. And they are separate. The centers of these both circles are, separated by a distance of 40 millimeters. Okay. With all that information we just gathered, we're going to create the drawing. Go to the front view, click on create sketch, click on the front view again, and what we can do is, yeah, everything is alright. Click on circle tool or C on your keyboard. Give the dimension as 5.7 millimeters in diameter. Zoom in for convenience. Again, C on your keyboard and create 10 millimeters diameter circle. And do the same thing over here. C again. Just select a random point on the axis. Give 5.7. Again, C. Give this as 10. So we can see that this one is in blue. We could resolve this right now. Uh, Go to the dimension tool or D on your keyboard. Click on the center of this circle and this circle. Give this as 40 millimeters in diameter. I mean, the distance between these two are 40 millimeters. Okay. But this is still in blue. So we're going to do the same we've done before, right? We're going to go to the constraints section. Go to horizontal/vertical constraint. Click on this. So what we can do is click on the first center, and while pressing Control, click on the second center, and everything is in black. So we've resolved the issue. Now what we can do is you can go to the line tool or L on your keyboard, and we're going to connect these both. But as before, we have to use construction lines again. Again, line and use construction. Hover over the mid, the center point, and make sure you create an intersection over here. Let's zoom out. Yeah, we've created this. Click escape. Again, we're going to go to line tool, construction. Make sure it's in construction. Wait, we haven't actually created it. My bad. Okay. Yeah. Now we'll create the second one at the bottom. Okay. Now that the both constructions lines are connected, we can click off of this construction thing and we can create the actual lines. All right, click on the intersection right here and we can see the tangent logo, right? The icon. And make sure you intersect the second circle. Sometimes you might be complacent and you'll be like, oh, I'll just connect it over here, but it won't be linked, right? You're gonna make sure it intersects over here. We can see the tangent icon appears on this set of the circle. Okay, click on it and again go to the bottom and complete the whole thing. Now we can see everything is in black, which means we are good to go. And we also see the tangent icons over here. But we still aren't completed yet. We can see that, in the drawing, we don't need these parts of the circles. So we can trim them out. T on a keyboard, right? We can see, take out the purple parts. Yeah, this part of the circle and this part of the circle. So yeah, we've completed the drawing. All we have left is, yeah, just give finish sketch over here, by the way. What is left to do is to create the model. Let's just go to the isometric view and take a look. Okay, let's go to the front view now. Now, what is the extrusion length? It is 5 millimeters in length. The width is 5 millimeters of extrusion. Go to the extrude tool. Click on the profile you want to extrude. Right. Go to the direction and give symmetric and make sure you give the measurement as whole length as well. And give the distance as 5 millimeters. Give OK. Now we can see this is the front view. Go to the top view, just as it is over here, right? And you can go to the isometric view. Now, yeah, we've completed the third component right now. All that is left to do is to save the component. Again, in the same folder as before. The name of this component is link. Let's make sure we enter that and give save. And as we can see that the third component is saved as well. We still have one more component to go through, but before that we'll have a small break. You can present your questions in the chat box. We'll make sure we can answer that. And also from here, Aditya will take over. So yeah, thank you.
Um, Thank you, Balashiva. That was really nice. If there are any doubts, I'll be taking them now. Okay, before we move on, we'd just like to show you what we can do with Fusion. So we'll be playing a short video such that it acts as a break as well. So here goes. This is one of the many projects that we do here at IEEE-RAS VIT. So I hope you guys are enjoying the session. And if you have any doubts, you can type them in the chat box right now. Okay, so I hope that was a good enough break. Um, we can move on to the next component. So, like Balashiva told, we are making a gripper basically today, and now we move on to the main part of the gripper, that is the grip. So, let's just start with our design. We click on create sketch and choose one of the planes. Which plane doesn't matter, but the front plane refers to the front view of the object, and most objects have the front view more defined than the others. So even we'll be sketching on the front view. So I clicked on create sketch and I'm selecting the plane, and you can see it gets highlighted as well. So we'll click on front plane, and yeah, now we can start the sketch. So what we first need will be a line. We'll take it for 40 mm here. Yeah, cool. Yeah. Next we'll need a circle um, on the right hand side of the line. So we'll take a construction line to draw the radius of the circle, which gives us the reference to the center of the circle. So we'll give 15 mm and we'll close the construction. Now we'll choose circle from here, or you can just type C on your keyboard. Either way works. I'll try to reduce the number of shortcuts I use during this session so that you all can follow as well. So yeah, let's just draw the circle. So that's done for the right part. Now we move on to the left part of the circle. You all can refer to the drive link that has been shared by IEEE-RAS VIT to refer to any of the sketches that have been made during this video. So yeah. Now we draw a line of 1 mm here. Next, we'll need a quarter of a circle. So like before, we'll be marking the radius of it to get the center. So from this point, I'm pulling a line to the left of 4 mm, and I'll be removing construction now, and I'll choose a circle. So yeah, we can draw our circle here. Yeah. Now we need only quarter of the circle. We move from vertical to horizontal here. So I'll just choose line, and we'll take a line from here. We'll draw it to 5 mm. Yeah. Now we can trim this off. So modify trim, and I can make sure that you only click on the left mouse button when it's highlighted purple, or else it might lead to some issues which we don't want. So I'm just gonna wait till it gets highlighted as purple and then click on the left mouse button. Yeah. Um, yeah. So the next thing we have is one circle. So I'll just be drawing that here. Yeah. Its diameter will be 5.7. Okay. Next, we'll just see the horizontal and vertical distance. So vertical is 20 and horizontal is 28 for this circle. So we'll just do that. Vertical 20 and horizontal 28. I hope everyone is following till now. Any sort of acknowledgement in the chat will help us also identify that. Next, we'll draw a 10 mm diameter circle here. Yeah. And now we draw a line from this point to the circle as a tangent. So you can see there's this symbol, a circle with a line. That's a symbol for tangent, and it comes on automatically. Yes, this session will be available later. You can view it anytime you want. It'll be on our channel itself. So yeah, next we'll do a small fillet of 4 mm here. So 4, done. And we can remove this 5 mm was not for that was just for our reference. We can just add a 5 mm length line here. So I basically the 5 mm was through the center of the arc, but now we are moving it a little, and we've got it over here. So here I can see there's an issue where there are two lines. I'm not sure why it's happened, but we don't want that to happen. So I'll just delete this line. Yeah, and I'll join this. Yeah. Now you can see there's a problem here. This point and this point is not constrained. So like Balasiva told, we always need to make sure that all our lines are black. Now because it's blue, I'm able to move it however I want. We usually won't want that. So what I can do is there are various constraints available. So I can give a constraint called vertical for the center of this circle and this endpoint. So we can click on this point, hold control and click on the upper point as well, and give the constraint called vertical. So now you can see we've got a vertical joint and everything is defined. So basically what black refers to in Fusion 360 is that everything is constrained and it won't be moving. If it's blue, it means there's some freedom you've given it and it can move somewhere. Yeah. So now we need another tangent line from this circle to this circle. Yeah. So we can just select this select line and move our cursor onto the circle, and you can see there's an X mark when I'm on the circle. That means the line will start from on the circle. So we can click the left mouse button, drag our line to the other circle, and you can see the symbol of tangent appears. So that means it'll become a tangent, so we can just click it that time. Now we want this line to be a tangent to this circle as well. How will we do that? Our body called constraints will come to our aid here, we can just click on tangent and constraints and choose the line and the circle. So you can see it gets defined now. Now we can just trim it off, trim the excess off. So we can go to modify, select trim and remove the excess circle. Even this is not necessary, so I'll be removing it. So from here we can see there's another circle here as well at 8 mm horizontal and 9 mm vertical. So we'll just do that as well. So click on C. Diameter is 5.7. 8 horizontal and 9 vertical. So let me just confirm it once. Yeah, we are right. So now that we are done with the sketch, we can just click on finish sketch. And so this cube is your basically your movement in the whole 3D workspace. So what I'm doing is I'm just holding the cube with the left mouse button and moving it around. So I can see various views of the workspace. So now, and when you click on the corner, it gives you an isometric view of the figure. So now I'll just extrude our part to 5 mm. Cool. Yeah. Next, we move on to the other part of the gripper. So if I can just show you what we're doing. So you can see there's a gap here, right? So what we did now is this, we finished this 5 mm part here, this whole part, but now there's a gap and then it's mirrored about the gap. So now we'll just create a new profile for the gap part and then we'll extrude that and then we can mirror the 5 mm part about the profile with the gap. Yeah, so we'll just do that. So now we can click on create sketch and select this face. Okay, selecting the face has its own advantages. All the paths that were there on the face before, you'll already have them preset. So basically, if you want to draw a line from the center of the circle, you can draw it with ease because you've selected to create the sketch on the face. If you create it on a plane, you'll have to project each of the uh, parts of the previous model onto it. So now we've chosen sketch on the face. Now I choose a line. I draw it for 8 mm. So there's some issue here. We'll just delete this extra line. Yeah. Now we can select line and we'll just draw a straight line of 8 mm. Yeah. Okay. Yeah. Next, what will we do? The distance of this line from the origin, we know it as 2.5. You can refer to this in the sketch provided in the drive link. So we've done that. Now we choose line and click on construction and we take a horizontal line and we take a vertical line as well. So once we are done with that, we can remove the construction and we can take the line and we can just connect these 2 points. So basically we've created the profile of the gap and you can see when I keep my mouse, when I hover the cursor over it, it gets highlighted. So yeah, next we can finish the sketch and we'll extrude it for 6 mm. So I'm selecting the sketch and I'll extrude it for 6 mm. Okay, I don't want them to be joined because we want to mirror just this part about the center. So in operation, when you're choosing extrude, you can choose new body here. So we are just choosing new body and clicking OK. Okay. Now we'll need to mirror this 5 mm part about the 6 mm part. And so the point where we will want to mirror it is 3 mm in front of the 5 mm part. Okay, so what we'll do is we can click on construct. In construct we can click on offset plane, so we'll select that. You can see there's planes here, but I can't select them because the body is in between. So I can just hide bodies by clicking on this eye icon here. I'm clicking on that and now the bodies are hidden and I can select this and I can give it -3 mm. So I'm clicking on OK. Now we've got that. Now I can show the bodies. Yeah. now I want to select the plane, but this body is coming in between. So I can select this arrow mark next on the left side of bodies and hide body too. So now I can select the plane and this body easily. So now under create, there's this option called mirror. So I'm just gonna select mirror here, and I'm gonna change the type to body because this has been defined as a body, right? Now the object is our first body, that's body one, and the mirror plane is the offset plane we just created. So I'm just clicking on OK now, and now we'll show body 2 as well. So we've basically created the gripper. I'll hide the construction plane as well. Yeah. So we've basically created the gripper, but it's in the form of 3 bodies. We just want it to be one body. How do we do that? In modify, there's this option called combine, and we can just join each of these bodies. Select the first one, then select the other two. Operation will be join, and then we can just click on OK. So we have created our gripper. Now we can click on save. We'll be saving it as grip. And where will we save it? So me and Balashiva are working on a joint workspace. So whatever he did before is visible for me as well. So he had created the gear, link and plate. Now I'm saving the grip. Yeah. So now we have saved it. Okay. So we are done with the individual components for now. So what we'll do next is we'll be assembling all the components that we've created. So I'm just going to click on new design. I'll just close the other two tabs. Yeah. Okay. Yeah. So now we have a new design opened. To make an assembly, let's first save it. Let's save it as claw assembly or gripper assembly, whatever you want to call it. Yeah. So I'm saving it as claw assembly. Make sure it's in the right location and then you can save it. Okay. Yeah. So once you've saved it, you can start dragging in components into it. So the first component we'll be needing is our plate. So I'll just pull it in. I'm just dragging it and dropping it. This is the what feature of using CAD software. They make work very easy for you. So I just dragged and dropped it. Now I'll just position it such that I feel it's in a comfortable way. It doesn't have to be moved. It's not necessary to move it. I just feel it's more comfortable when it's just above the origin, in case I need some reference. So I'm gonna click on OK now. So what are these things, you may ask? What are these various arrows? These round icons allow you to rotate the body around this point, and the arrow marks allow you to move this body. The square plates allow you free movement in that particular plane for you to move up around the object. Yeah, so now I'm clicking on OK because it's in a satisfactory space for me. So I'm clicking on OK now. Yeah, so the next thing we'll be bringing in is a gear. So I'm just gonna bring in our gear. Okay, and I'm just gonna position it in a way that will be helpful for us. This gear will go and sit here at this hole of the plate, right? So we'll just roughly align it for our reference when we join them both. Yeah. So now we've gotten our gear. We'll click on OK. So in any assembly, you can observe that there'll be one point which is there'll be one component which is always stationary. That will act as a reference point for all the moving bodies there. So in our case, that's a plate. So I want to make the plate not be able to move. So how will I do that? I can right click on plate over here, and there'll be this option called ground. If I click on that, I won't be able to move the plate. So that's done. Now I can just join them using the joint option and assemble. I'm clicking on joint. I'll first select the circle of the square over there. As you can see, it gets highlighted when I hover over it. And same way, I'm gonna hover over this circle and I'm gonna left click. Yeah. So now they've been joined together. Now I just have to change the motion to revolute. Yeah, because it'll have to revolve around that point. for our final design, and I'm just gonna change it a little, the position of this gear, so that it becomes easy for us to add the other components later. So I'm just clicking on the circle icon and tilting it upwards. So now I'm going to click on OK. So this seems satisfactory, and we've joined our first two components that were created. So next we'll be bringing in our link. Just drag and drop, not much work. Yeah. So we just wait for some time for it to load. Yeah. And now we can move it about. So same way, I'm going to move this here, move it a little back. This circle should get joined with this circle. So we are just going to roughly align it for our convenience and click on OK. Now I click on joint, and first I'll select the link, this point of the link with this point of the plate. Yeah. The motion is already revolute, so I don't have to worry about that. I just have to worry about tilting it a little for bringing our grip later. So let me just tilt it a little. Yeah. And now I'm going to click on OK. Yeah. So we've brought in our link and gear. Now we'll have to do the same thing on the other side as well. So I'll just quickly do it. I've explained it for the first time, and I hope you can understand from that. I'll just go a little quickly for the other side. So I'm just gonna place it for my convenience. Click on OK. Now click on joint, align it. Change the view so that I'm comfortable working with it. Yeah. Now I'm just gonna join these 2 points. Yeah. I use the same Revolute. The motion has already been set in Revolute, so I don't have to worry much. And I'll just tilt it a little so that it's easier to bring the gripper later. Next we bring in the link as well, and we do the same thing on the other side. So click on OK, join, choose the right circle, and choose the right circle here as well. Yeah, now they're joined. So I'll just have to tilt this out and click on OK. So we've almost completed our assembly here. We just need to bring in our grip. So the grip we created, I'm bringing it in now. Okay. I'm just gonna place it such that it's more easy for us to work with it, and click on OK. Now this grip has to be connected to both the gear and the link. So first I'll connect it with the link, click on joint, select this inner circle of the grip, and we'll select the other side of the link here. Yeah. So now you can see it's aligned, but there's one thing we did different here. So what we did was, when we created this, we made a gap of 6 mm here. So you can see there's an uneven gap here. In real life, you'll be putting a washer or something there, uh, just to leave some space between the moving parts. So I'm just gonna replicate that and add a small gap of minus 0.5. How am I doing that? I selected this arrow, moved it a little, and here I'm typing in minus 0.5. So that's done, and I'm clicking on OK. So we've joined our grip with the link now. We'll join the grip with the gear as well. So click on joint, select that part of the grip and the other part of the gear here. And let's do the same thing. We need to give a gap, right? So we'll just move this arrow a little bit, minus 0.5, and yeah, that's done. So yeah, we've done the first half of our grip. So you can see we've got our first movable part in this assembly. And you can see it's moving as we want. There's no problems with it. So you can also constrain these joints such that they don't intersect here, but due to time constraints, I won't be covering that now. But yeah, even that option is there. You can just left click and in edit joints, you can do that. So yeah, you can try that later. I actually encourage you to try out everything we are doing now, as it'll help you start on your journey in Fusion. We'll bring in the other gear now. Place it a little better. I'm gonna turn it around because it's for the other side. 180 degree. and I'll just position it a little better for me to be able to access it easily. So yeah, okay. So now we'll join the grip with the gear as well again. So click on joint. Let's do it with the link first. So here we have the link and we've joined both. Motion will be revolute. It's already been set. The only thing we have to do is give that small minus 0.5 thing we did space. So we can just click on that arrow, select this one here and make it minus 0.5 and click on OK. So that's the first part done. For the second part, we can click on joint again, select this part and select the gear. We are just making the circles coincident here, nothing more. So yeah, next we'll be moving this arrow and making it minus 0.5. You can see every time I'm adding that other joint, because there's this 1 mm gap there, I get a warning as well that this won't be a proper joint and it won't be able to complete the task. So yeah, you just have to take care of these small things. So we've completed our assembly here. We've got a gripper for ourselves. So if you guys want, we can take a short break here, but if you want me to continue, we can go on. Okay, so we are done with the assembly now. Now I'll just like to tell you a little bit about 3D printing. Okay, so we are going to 3D print one of these components. And before that, I'd just like to tell you all what 3D printing actually is. Okay, so what we'll do is just go to a small presentation on what is 3D printing. So let's go. Okay. So 3D printing is also called as additive manufacturing. Um, yeah. So what is 3D printing? 3D printing or additive manufacturing is used to generate a 3D object by depositing layers of material successively. Yeah. So I hope everyone knows about 3D printing, has seen some videos on YouTube about 3D printing. So yeah, that's what 3D printing is. We are basically bringing a computer model into the real world layer by layer. So that's what 3D printing is. And how to 3D print is, first we get a CAD model and then we generate a G code for it and give it to a 3D printer, and then that'll print our model layer by layer. Yeah. So now let's see how 3D printing actually started. So additive manufacturing can be traced back to the 1980s, but the very first patent that was of 3D printing was in 1984. And this method of 3D printing was actually called as SLA, or stereolithography. Okay, so that was the first form of 3D printing. So yeah, moving on. What is SLA? So we told that the first form of 3D printing was SLA, but what is it? So SLA, or stereolithography, is a type of watt polymerization 3D printing. So what happens in this process is that, as you can see in this image here, there's a laser source and that'll be leaving a laser beam towards the surface of the liquid, and then that liquid gets hardened wherever the laser has heated it up, and then we get a final model that has been created. So this is what stereolithography is. Yeah. Next. The present, we have many forms of 3D printing, and they are mainly classified into extrusion based, resin based, and powder based. The extrusion based forms of 3D printing are FFF, that's fused filament fabrication, and FDM, fused deposition modeling, and bioprinting, and LMD, which is laser modeling, and SLA, stereolithography. SLS is selective laser sintering. We'll just look into a few of these, right? I hope it's informative to all you guys that learning about 3D printing, as it's a happening technology and might have very serious applications in the future. So the first, we have fused deposition modeling or fused filament fabrication. So yeah, the idea behind this is that we have a spool of filament, As you can see in this image here, we have a spool of filament which gets fed into a heated part, a heater which melts the filament, and then we have a nozzle which extrudes the material depending on the layer thickness we have given and starts depositing it layer by layer, thereby giving us a model, as you can see here. So yeah, that's what FFF or FDM is. Next, we move on to the next type of 3D printing, which is called LMD or laser metal deposition. So laser metal deposition is a generative manufacturing method for metals. So what makes this unique is that it requires a base surface. So it requires something to be there before. So what LMD does is that it sprinkles powder first, that's metal powder, and then it heats it up, solidifying that part. So LMD is pretty unique among 3D printing. So yeah, that's LMD. Next, we have another watt polymerization technique called digital light processing. It's very similar to stereolithography. The only difference is that instead of laser source, you'll have UV lighting here. And it gives you very accurate prints. Yeah? So yeah, now one of the very popular forms of 3D printing, selective laser sintering. The advantage of this is that it can be used for metals as well. So SLS, let's see how it works, right? I'll just go to the image now. So you can see there's a layer of powder here and there's an overhead laser which will be heating up the powder and solidifying it. Okay, and then once one layer has been solidified, we have a slider which comes and deposits a new layer of powder over it, and then the laser hardens that as well. So at the end you'll be left with a block of powder that looks like this, and when you open it, break it open, you can see your formed hardened parts model over there. So the advantage of this is that it doesn't require any form of support. So other forms of 3D printing requires support to also be printed. Here we don't need support because the powder itself acts as a support. So that's an advantage. It saves us cost as well. Yeah. So what's the future? So 3D printing, as you guys know, has a lot of potential and most probably will lead to the fourth industrial revolution. It helps us in creating very products very quickly and in a very custom manner. So it increases the diversity of our products. It also creates products with superior capabilities, and they are also they can also be open source where you can just create a design, send it to someone, and they can 3D print it for you and bring it to you. So yeah, that's the advantages of 3D printing. So now we'll see how to 3D print our model that we created just now. So yeah, um, we come back to our Fusion 360 screen. Let's save our assembly now first before we move on. So I'm just clicking on save and clicking on user save. Okay, you can see every time I save it, this V0 became V1. So that's and V1 becomes V2. So basically each time you save it again, a new version of the product is created, and this helps you keep track of how many iterations you've gone through of the model. So what will we 3D print today? So let's 3D print our gear. So I'm going to open gear, which was created by Balasiva earlier. I'll just close the claw assembly for now, and we'll see how to 3D print our gear. So first we go to the manufacture tab, click on design, and you can see a drop down menu and click on manufacture here. I'm clicking on manufacture now. Okay, now we need to set up our 3D printer, which 3D printer we'll be using, what will be its layer height, what material will we use, etc, etc. So we click on setup here, and now we select our machine. So the machine that we select will be you can go to Fusion 360 library here. I've selected a few printers before, so my recent is filled with 2 printers, but you probably won't have them. So you can click on Fusion 360 library first. Yeah, click on this drop down box and you can see various company names. So these companies produce 3D printers, manufacture 3D printers. So let's go to Creality, and let's choose CR10. You can choose any 3D printer, it doesn't matter. So I'm selecting the Creality CR10 right now. I'm clicking on select. So you can see it's brought in the 3D printer, like the dimensions of the 3D printer into our view. So now we'll have to place this onto our 3D printer. Before we do that, let's just see what else we can do in setup. It's saying print settings. Let's click on select for print settings. So here you can see it'll probably be empty for you here because I've used a few filaments. It's showing them for me. You can click on Fusion 360 library here, and you can see there's various materials available already. So you have ABS, PLA, and yeah, you have CPA as well. So you have various materials available. So I'll use ABS for now. Now the problem with Fusion 360 library is that you can't edit anything in it. So the layer height is given 0.2 mm. You can't change it here. So how do you change this? So you can copy this. You can just click on copy, and you can go to local and click on paste. So what this allows you is it allows you to edit the settings. In Fusion 360 library, it's already prepared by Fusion 360. You can't edit it, but if you want to edit it, you can just copy it and paste it in your local cloud, and you can just edit it here. So you can click on this pencil, edit, and here you can see various options available. You can see you can edit the layer height, you can edit the extrusion width, you can edit sparse infill density. That's a density of how much you'll be filling each layer and how much space you'll be leaving. And there's various infill patterns as well. So rectilinear, star, honeycomb, that'll be the type of printing it'll do. You can look into it a little more in your own free time. I'll just select rectilinear for now. You don't have to change it as well. You can just go through this in your free time. And I'm gonna click on OK. I'm not editing anything else, and I'm gonna select it. Sorry. Yeah. And I've just selected it. And now the operation type will be additive. That's 3D printing. And we won't change anything else. So I'm just gonna click on OK. So now we just have to place the model properly. We don't want it in this orientation as it'll waste a lot of space. So we'll just turn it a little. How do we turn it? So you can choose the move option here. Click on the model, click on the body, and you can just rotate it. Okay, and save it. So why am I doing this? As you saw in the previous image, it would have required supports, and that would waste material as well as waste our time. So if we want to reduce material wastage and time wastage, we'll have to do this. Okay, so yeah, now we've placed our model on the 3D printer bed, and I guess we are good to go now. So I can just click on generate, and I can click on simulate. So using CAD software is helpful for these reasons. You can simulate the print now. So as you can see, I can click on play here, and you can see how it will be 3D printed in real life. So you can see it being 3D printed, our circle. So yeah, our gear has been 3D printed now. So yeah. So once it'll be done, you can see it. So it takes a little time, but it'll be done eventually. So you can see it completed. So now we can click on post process to generate the G code for this. I'm clicking on post process here. Now we can just choose where to save it, and we can change the file name. So I'll say G code FusionVerse here. So now it's been saved. We can click on post here, and now it will show you the G code that has been generated. So yeah, here you can see that it's generated the code for our 3D printer. You can see that it's generated the code for our 3D printer. You can see various commands here, G1, etc. You'll be learning this in the future, in our future sessions on 3D printing. So yeah, we've generated the G code, and you can take this to a 3D printer and it'll print your model for you in real life. So in this session, we've created a 3D model, we've brought it into real life. What else can we do with Fusion 360, you may ask? So I'm going to go to the claw assembly again. So in the beginning, Balashiva showed you a image of what we did, but it wasn't so boring like this, right? It wasn't just all gray. It looked cool. It had a red light below it, and it also had various colors. It was black, it was gold. So how do we turn this into that? Okay, so what we did there is something called a render. So when you've created a product and you want to give it to someone, you want to show it to some investors, you'll have to make it look good, right? It'll have to look good to sell. So you can create 3D, you can customize your 3D models to make them look good, even though they won't be the final product, like the design specifications will be of that, but you can make them look good, or you can see how they look in different locations, and you can test your product in the virtual environment itself. So yeah, we'll go to the render window now. So click on design, drop down box will appear, and click on render there, and we enter into a new window here. Okay, so this is our render window. As you can see, for now it looks plain and simple, nothing like what Balashiva showed. So I'm just gonna move everything a little bit. Yeah, so now we can assign materials to what we created. So now, since this is a render, I won't be taking physical constraints into respect here, and what we'll be doing is we'll just choose materials that might look good in a render. So it might be highly reflective and it needs to have a nice finish. So yeah, we'll choose materials like that. So I'm gonna left click on this face and select appearance. So when I click on appearance, you can see there's various designs that come here under the library of Fusion 360. You can see there's various appearances. Um, for my convenience right now, I'll go to metal, and I think chrome has good reflective properties. So we'll select chrome and we'll choose chrome black. Now, how do I apply this? I can just click on left click on chrome black and pull it and drop it on the grip, and it gets highlighted, as you can see. So I'm bringing chrome black and putting it on the grip, and I'll make the plate also as chrome black. Okay, so make sure the right part is highlighted, and yeah, so we've got chrome black on our grips and the plate. So next, what will we do? Let's add gold. Let's make it gold. Gold's pretty reflective, so we can make our link and grip as gold. So let's bring gold. I'm just dragging in and dropping it on the gear and link. Yeah, and now I'm gonna close it. So we can see we are getting somewhere. We are getting a sort of good design being created here, a highly reflective design, and you can see that there's a light source somewhere. So this is the render environment of Fusion 360, and it basically gives you a real life view of how it will be. So yeah, now I think I'll need a light source below it, so I might need an LED below this. Okay, so what will we do? So we'll need some surface to put our LED on, right? So we can go back to design. Nothing gets deleted, everything gets saved. Okay, so we can go back to design, and now we'll just need to create a small plate like face so that we can attach our LEDs. So I can click on create sketch. I'll choose the top plane itself. I'm gonna capture the position. I don't want anything moving anywhere. So yeah, now I can choose a circle here. Once you guys get used to it, you can start typing and see. I'm trying for you guys to follow along with me, so I also won't be using any shortcuts for now. So yeah, we'll draw a pretty large circle, and we can just offset the circle a little to get a sort of plate like structure. I'll just extend it by 3. Okay, yeah, let's just say around 3. I'm not keeping track of like the exact dimensions because it's just for a plate. Yeah, okay. So next, we'll just extrude this part. Let's give it a -5, let's say. It doesn't matter what thickness you give because we'll just be adding the LED on the front face only. So I can click on OK. I need to make a plate-like structure, so I want the outer edges to be like a wall. So I can just click on sketch and bring back that sketch, and again click on extrude and make a small sketch here. So let's just bring it up a little and click on OK. Now I'll hide the sketch. We are done using the sketch. Now this body is intersecting with our grip. I don't want that to happen, right? I can just click on move. I can select this and I can just move it down however I want. This isn't joint for some reason, so we'll just check that why it's not happened. Click on join, click on OK. Yeah, now it's been joined. Yeah. So now I can select move, I can select this part and I can just pull it down to a suitable distance such that when the LED glows, if there's some reflection onto this. But I don't want the LED to be seen basically. So yeah, we are done with that. Now let's go to the render uh, part of it again. Yeah. Okay. Now we need to add LED on these faces. So just select this, click on appearance here, or like I told before, right click and select appearance. Either way works. I'm clicking it up there now. So now I need LEDs. It's a little difficult to search for them, but when I know what I need, I can just type it in the search bar, LED. So let's see what Fusion has. Fusion 360 appearance library, and you have various LEDs here. Red seems like a good color, so I'll bring in red, and I want red on that face as well, so I'll just put red there. I'm gonna close it. Yeah. So now I'm not sure how much brightness this has, so I can just check that out here. I can click on appearance, I can double click on the LED and you can see how much luminance it's giving. So I'll set it to 2000 for my convenience right now and click on done, and I'll close it. Yeah. Now we've almost completed the render. We'll just have to set the scene. So go to scene settings and you can see there's an option to set the brightness. I'll leave it at 1000 for now. And for the background, I'll select environment. Why am I selecting environment, you may ask? I don't need a ground plane because ground plane creates a surface of light below your model. If you want the ground plane, you can keep it. For now, I don't need a ground plane. I'm gonna remove it. The camera will be my perspective itself. I won't be changing that. Now, why did I select the background as environment? Selecting the background as environment gives me access to the environment library. So the environment library has various options. It gives you various kinds of lights. Okay. For this, for what I'll be doing now, I'm gonna select warm lights. And like I told before, right, there's why we use rendering. So you can see here, there's various other options like plaza, field, skylight. So why you render is so that you get to know how your product looks when it's brought into some real life environment. So that's why you use render. So yeah, now we have a pretty good looking model here. So let's just make it place it the right way. Let's get our perspective proper and yeah, zoom in on our required part a little, and yeah, I think we are good to go. So when you're good to go, you can click on render here, and render quality, please set it to standard. Final requires you to pay money, and if you're a student, you probably wouldn't have paid for Fusion 360 and for rendering at least. And you can just do that and click on render here. And it takes some time to render itself. So if there are any doubts, I'll be taking them now till it renders. So if anyone has any doubts, you can ask me now. So yeah. So by the end of it, when it's completed, I think it'll look like this. This is how it should look. This is how the render should look. So yeah, um, that's it for this session. I hope you guys enjoyed. So let me just summarize what all we taught you in this session. So first we brought you into Fusion 360, how to get started with Fusion 360. Then we started making this assembly over here. So first we made the single individual components. We made the plate, gear, and then we created the link. Then we created the grip, and after that we assembled our components such that we get the movement that we would require in real life as well. And after that we spoke about 3D printing, the various types of 3D printing, what all and what newer technologies are available in 3D printing right now. So yeah, we also did a demo on how to 3D print in Fusion 360, and we generated the G code for it. And then we went into rendering, how to render your 3D models to make them presentable and to see how they look in different work environments. And yeah, we completed a render. So I hope you all enjoyed this session. If there are any doubts, we'll be on our IEEE-RAS community server. The link will be provided in the chat. You can join us there for any queries you have on this session. And it's not necessary that you have to come there now itself. You can type your doubts when and where you see this session. If you are in the live stream right now and you've seen it, you can come join us now. If you join us later, you can just drop in there and type in your doubt, and we'll clarify it as soon as we can. So that's been it for this session. I hope you all enjoyed it. Now, IEEE-RAS conducts many more sessions like this. We've already had a session on electronics and software earlier, and we'll be having our recruitment soon. So if you're interested in robotics and you're in any domain, let it be CS, EC, EEE, or mechanical, or any other department, but you're interested in robotics and automation, we are willing to take you in. So if you're interested, contact us on the community server itself. We'll add you to the recruitments. We'll let you know the procedure for it. So this has been Aditya and Balasiva as well, and this has been the session called FusionVerse by IEEE-RAS. Thank you.